Hello everyone, I'm sorry I can't be with you in person today, but I'm excited to be part of this event. Thank you to Masa, Niha, and Shay for organizing this and giving us the chance to present our work in light of Kai's cancellation. So today I'll be presenting, on behalf of my co-authors, our work investigating ways to design for gesture frame of reference when developing systems that seek to externalize ideas for common ground from the user's gestures. It's a mouthful, but hopefully it'll all make sense by the end. We know from everyday conversations that as we communicate with one another, our mental images of what we're describing and trying to get the other to understand don't always match. Oftentimes, in order to establish some form of common ground with each other, we must stop conversational flow and reach for expressive medium with which to communicate our ideas. To prevent this interruption and better support the establishment of common ground, this project investigates the design of a system that translates the user's gestures and speech into visualization of their ideas. So we have an example shown here, with users engaged in a product design task as our potential system visualizes their ideas into a shared display, all during the flow of conversation. This study is an initial piece towards this goal, where we share design implications for such a system derived from analysis of speaker frame of reference, specifically while engaged in dimension or size describing gestures. In our previous work, we conducted an analysis of iconic or image-describing gestures produced during storytelling tasks, and we found that gestures conveying different meanings had varying degrees of consistency in their physical features. In gestures that describe dimension, as in the height, width, or length of an object, the most consistent physical features were found. Dimension-describing gestures tend to have a mirrored hand movement with a flat hand shaped and the meaning embedded in the distance between the two hands. An example from one of our participants is shown here. For the first prototype of our system, shown here in its development phase, we used these features of dimension-describing gestures to implement a system that could visualize a two-dimensional object between the hands using open pose and unity. To better contextualize the specific analysis I'll be discussing today, in our system, we investigated the accuracy of the system and what factors affect its performance, as well as potential uses. The full results of the study will be published in API 2020. This analysis is a small piece of our investigation into what different factors impact the performance of a system that aims to visualize gestures, specifically looking at how we can design for speaker frame of reference. So of course, by now you're wondering, what exactly do we mean by a speaker's frame of reference in the context of gestures and this study? In plain terms, it can be understood as the way a speaker grounds their description of some object. A speaker's frame of reference can be determined by understanding the relationship between the figure, the object being described, and the ground, the object being used in relation to the figure. This relationship is characterized by a frame of reference anchor, of which there are three possibilities: the absolute, intrinsic, and relative anchors. In this example, adapted from Danziger's description of the different frame of reference anchors, we take the coin as the figure, or what is being described, and the die as the ground object. Understanding the absolute anchor is pretty straightforward. It is characterized by when the speaker makes use of a fixed coordinate system. For example, I would say the coin is 2 inches east of the die. Next, an intrinsic anchor incorporates a description of the figure in relation to the ground object. For example, I could say the coin is by the to side of the die. And a relative anchor is being used when the speaker makes use of their own viewpoint. For this anchor, based on the viewpoint of the speaker shown in red, you would say the coin is to the right of the die. Note that this is similar to the intrinsic anchor, but the key difference is the description of the object depends on the viewpoint of the speaker instead of the inherent traits of the ground object. And this concludes our crash course on the different frames of reference, and you all get a certificate, yay. So now on to our study. During the study, participants were asked to describe the size of GIFs for 16 cartoon characters. The system would alternate between a virtual character and a live person as the system guide. The setup for our study is shown here, with the participant sitting before a monitor displaying our system, and the researcher managing the system from behind the one-way glass to the left. Our system was conducted with 26 participants, 20 of which we had full data for due to system errors. Recruitment was conducted via our department's SONA participant recruitment system. For our analysis, we extracted the recordings of the participant describing the size of the gift. 4 characters were randomly chosen of the 16 per participant due to the effortful nature of gesture analysis. In total, this meant that 84 tasks were analyzed, with 172 gestures identified from these tasks. Our results for this paper are observations from use of frame of reference during these size describing tasks. 2 coders identified the frame of reference for each gesture and recorded the associated speech. Intercoder agreement was established over 10% of the selected data over 2 rounds of discussion. Though additional observations were made, today I'll only be presenting our implications for design by frame of reference anchor, which is based off of our observations and our emergent coding scheme. Please refer to our paper if you're interested in our full results. It should be noted that these results only reflect upon size-describing gestures, and more research may be needed to fully generalize them to all gesture types. In our results, we specify implications for design for the detection of a gesture's frame of reference and for translating them into meaningful visualizations. So first we start with implications for the design of our system's ability to detect a given gesture's frame of reference by anchor. For the absolute anchor, it can be assumed the gesture uses this frame of reference if exact measurements are spoken, or if the gesture is produced without mentioning a ground or any accompanying speech. No speech would indicate that the size of the figure is being defined by the exact size of the gesture. Typically, gestures are produced in the flow of speech, but we notice that for the absolute anchor, there are multiple cases where the participant gestured the size of the figure without saying a word. For the intrinsic anchor, the system would need to search the speech for the specification of a ground object, followed by comparison terms in relation to said ground object. For example, a little wider than or half the size of would be examples of comparison terms. For relative frame of reference, the gesture likely uses this anchor if the speech is self-referencing, or if the gesture shows an action being performed by the speaker. In the case of this study, which focuses on size-describing gestures, an example would be the participant making a tucking motion saying, the figure should be small enough to fit under your arm. And now, our implications for the design of our system's ability to translate a given size-describing gesture into a visualization given its frame of reference anchor. For the absolute anchor, it would be necessary to scan the gesture's accompanying speech for a unit of measurement, which would then be represented in the visualization space. In the case that no speech was produced, the physical size of the gesture should be taken as the literal size of the figure. For the intrinsic anchor, after determining the ground object in terms of comparison from the speech, a change in scale would then be assessed from the speech. For the relative anchor, the visualization space would require a representation of the speaker. The object would then be sized by a ratio of the gesture to the speaker's body and the implied ground, which is typically the character. For example, if you're gesturing for the size of a house for a character, say the size of the cat, and you make the gesture above your head, you're using yourself in place of the perspective of the cat. The final size you're trying to indicate isn't above your head, rather above the cat's head. In conclusion, we analyzed size-describing gestures for their frame of reference and observed interesting trends in how participants gestured during their use of our system. We drew implications for design from our observations and our coding scheme. Thank you for listening. If one of my co-authors is available, they can take questions at this time. Otherwise, feel free to shoot me any questions you may have via email. Thank you.